Hi, I am Jean-Daniel Fekete from the University of Maryland. I will present you my work on visualizing 1 million of items. So what are the limits of information visualization? How many items can we see and understand before we need to aggregate? To answer this question, we have designed a set of techniques to push current information visualization techniques to their limits. By using on-the-shelf accelerated graphics cards, spatial graphics and interactive techniques, we can display about 1 million items on a regular screen with a decent interactive feedback. Let's have a look at these techniques with Treemaps and scatterplots. This is a Treemap showing the file system of a large Unix server containing about 1 million files. Each file is represented by a small colored rectangle. The whole screen represents the whole disk space, 35 gigabytes. The screen is split among the top-level directories. Each directory is split recursively until all the files are visible. Here, 33 levels are visible, colored by file types. To be able to see a million files, every pixel has to be carefully used. For example, rectangles are not outlined. Instead, the color is not uniform across the rectangles. The top-level corner is brighter, whereas the bottom right corner is darker. In between, colors are interpolated. This creates a phenomenon known as MAC bands, where the visual system increases the contrast and reveals the borders. The colors are assigned according to the type of the file. Executable files are in red, text files in blue, images in green, source code in yellow, multimedia in magenta, files of unknown types in gray. Directories and similar files are in white. Some patterns are visible. The mix of blue for text and green for image usually represents websites. Some directories also contain code in yellow and executable in red. Similar subdirectories are visible, probably showing multiple versions of a large program. Even such a large Treemap can be analyzed, reveal patterns, and support discoveries. Here, this large gray rectangle is a bug discovered by this visualization. A program that translated email messages into web pages has failed to remove thousands of temporary files that accumulated for years. Such discoveries are common when just looking at the whole file system of a hard disk that has accumulated years of work without supervision. Let's see how we can use interaction to further analyze this large amount of data. Dedicating a portion of the screen for menus and control panels would misuse too many pixels, so all controls are local to the mouse pointer. The name of the file under the mouse is displayed at the bottom right of the screen when the mouse moves. Left-clicking on the visualization shows the hierarchy at that position in a menu. This menu can be dragged and display the rectangle at each hierarchical level with the labels at that level connected with a line to the center of their position. By releasing the menu, I zoom and explore subdirectories in more details. Color assignment can be changed to show modification dates instead of file types. View configuration can be recorded and played back using the arrow keys. Flipping color configuration helps comparing the relations between two attributes, here file types and file creation date. In this directory, we can see that the files are older than in the rest of the file system. Let's change our dataset to visualize some information about the Census 2000 data now. It shows the population by state, counties, and county subdivisions. When exploring datasets, different techniques will show different phenomena. For example, we can change the layout algorithm to several Treemap layouts as well as the scatterplot layout. When doing so, the visualization changes dramatically, making it very hard to understand where some regions of interest are now located. To help understanding this transition, we animate transitions. For examples, when changing from the squarified Treemap layout to the strip layout, we can see where large blocks moves and realize the relationship between both algorithms when we become more familiar with it. Let's visualize the dataset with a scatter plot. It reveals the geographical density of population of the United States. When changing the axes, an animated transition helps perceive patterns if there is any. Coming back to the Treemap representation, we can zoom into a state to analyze further its population, and switch to the map where the animation shows where the state is located. Our examples show that information visualization is still useful and practical when interacting with 1 million items. It requires new display techniques and to rely on graphics card acceleration to achieve the speed and density needed. The next step will be to understand what level of training is required to make the best use of those high-density visualizations.